Hello, everybody. I'm Fritz. I'm from Hamburg, Germany. In school, we're not doing show and tell in Germany, so I need to hold on to a piece of paper. I'm not used to this situation. So, as other speakers this morning introduced us to new worlds in our galaxy, outside worlds in our galaxy, or new worlds within, speaking or looking at our genome and so on. I'm going to speak about having a new look at the world that we already seem to know. And so I'm talking about some pretty pictures, really. I'm working with a company called The Marmalade in Hamburg, Germany, and I'm the developer of a high-speed motion control system called Spike. Now you see a picture of it there. So what is Spike? Spike is basically a robot that can move around a camera really, really fast. So what makes it unique is a software that I wrote that can take this raw capability of moving a camera around fast and turn it into a useful creative tool, and a tool that helps us see images that we've never seen that way before. So before I go on any further, let's have a look at what this means. And please roll video number 1. So everything that you just saw happened for real. This is now 3D animation. And everything that you saw happened also in very, very short time spans, a couple of hundredths of a second. Now, Spike can catch these moments, and by moving a camera in just the right way and at just the right time, reveal the beauty of the action that is happening in a way that hadn't been seen before. Now, slow motion filming in general has been around for over 100 years, for quite some time, and it has been used and refined ever since. But what had been elusive was a way of moving a camera around during filming. The cameras were typically way too big and way too heavy and way too delicate to be moved around. And even when a new generation of digital high-speed cameras removed these barriers, a fundamental problem remained, which is that it's incredibly hard to catch and follow the right moment for some action that happens within a fraction of a second. And this is what Spike does. You see, the idea for Spike came up in 2007, and it was my colleague Jan Gwiazda over there who had it. And it came about as follows. So Jan was working as an effects specialist on a beer commercial. And so the creative team, the director and the writers, they had the idea of a shot that would follow a stream of liquid as it leaves the opening of a bottle, falls down and collides with the bottom of the glass. And they wanted to have this shot very much, and so they tried it with classical means, moving a camera, going 3, 2, 1, go. Somebody pours out the beer, somebody moves the camera, but it turns out it was just too hard to do that. You know, they worked an entire day on that shot, and they didn't get it. They just couldn't get everything into place at the same time. So either they didn't get the timing right, or they moved the camera too fast or too slow, or not to the right point. So an entire day was wasted. And Jan was observing that, and we had a flash of inspiration, which is that was what was basically needed was speed and precision in this situation. And these are disciplines that industrial robots excel in, speed and precision. So why not attach a camera to such a robot? It turns out that there is a fundamental problem with that, which is that industrial robots, as the name implies, are built for manufacturing. So typically, it takes a couple of days to set up a robot for a particular task, but it doesn't matter because they then repeat this task over and over again, and sometimes for years. So that's perfectly okay. And very often it's also that they only need to find some very specific positions, like where to pick up something from a conveyor belt and where to drop it on another conveyor belt. And it doesn't quite matter how they get from here to there, as long as they don't hit something, you know, along the way. And for filming, that is quite different. Now, it matters very much how we get from here to there, because in between, all the magic is happening. Yeah? And it also, you need a much better ratio of setting up something, setting up a computer, a robot move, and how much you, or how many times it's being performed. Now, ideally, you want to get everything on the first take. So you program something, you shoot it, and you want to be done with it and move on to the next thing, which is quite different from, you know, taking a few days and then doing it a million times over and over again. So it was clear that there was something in that idea of using a robot, but it wasn't quite there. And this is where I came onto the picture. So if we roll video number 2, please. Now, Jan and I, we both work for a company called The Marmalade in Hamburg, Germany. Now, we produce commercials, and they often involve a great deal of special effects. And these are sometimes more obvious and sometimes less so, but they are always there. So The Marmalade was created about 9 years ago by 2 groups of people, and both had a background in filming and in special effects. But they both had very different approaches. So some of us, like Jan there, have a classical special effects background. So they do everything, approach everything in a physical way. They build models, they create rigs for performing some particular task, or they blow stuff up. Others in the company, like myself, we come more from a post-production background. So we're working with computers and with software to do everything. So the idea was, why don't we team up? And instead of having to solve every creative assignment by either blowing things up or by pushing software buttons, we could actually find a way that uses both approaches. Sometimes this is more using the screwdrivers and the drills, sometimes this is more using the software buttons, and most often it's a combination of the two. We work at the intersection of what I call coincidence and control. So we use nature in its inherent beauty as our raw material, and then by using our tools, we bring the beauty of the action forward and get rid of what's unnecessary or random. And it's a bit like a sculptor who works a sculpture out of a stone. You know, it's already in there, but you get rid of all the parts that don't look like you want them to look. So the more refined the tools that we use are, the more intricate the interplay between the real physical world and our imagination can be. And this is, again, where Spike enters the picture. So filming is a creative process, as you all know, and a creative process is characterized by exploration and iteration and refinement, and then also beginning all over again. And so any tool that you use for filming should support that progress and not be in the way. Now, it's a fundamental divide that often happens with tools, like does your tool determine your aim, or does your tool help you reach your aim? Now, this is a very important thing. So for us, that meant we had to write our own software to use the capabilities of the robots that are already there and to make them work in our context. Because even when I had a concept of how that robot would work, and I approached people who had experience in programming these kinds of robots, it became clear that we came from, let's say, very different exoplanets. You know, the divide between people who are very technologically or technically minded, let's say, and who are creatively minded, there's a very big gap. So at some point, I figured out that it would be easier to teach myself about programming and about how robots work than to teach other people how a bunch of creatives and their clients on a film set work. And so this is how the system came about. And if we roll video number 3, please. So this is how the system works. You know, you have a software, and you can basically just draw like an illustrator, so the trajectory of how the camera moves, and it can pull its own focus, and you can even, you know, simulate what you want to do before to make sure that you just catch the right moment. And you control other stuff. I can control how the bottle, you know, moves just at the right time to make the glass fall, and then the camera exactly follows the trajectory and gets there. So Spike helped us to, you know, to move the bar of what is possible in our field of work. And there are great people here, and as Jim is saying, he wants to encourage serendipity. So if in your field of work you have an idea how such a technology could help you, don't hesitate to approach me later. Thank you.